Good morning, good afternoon, good evening. This is Frank with the EMEA vBrownbag, and today we are joined again by Andrea Florio, who already did section 3 of the CCNA data center curriculum with us. Welcome, Andrea.
Hello everyone. Thank you, Frank, for inviting me here again.
Yep.
Hope we will go through this session smoothly like last time.
I'm sure we will. So yeah, just for folks on the call, if you want to get in touch, use either the vBrownbag hashtag on Twitter or tweet one of the accounts. The webcasts run in basically every major region. For us in EMEA, it's every Tuesday at 7 p.m. GMT. And with that, I'm gonna hand it over to you, Andrea.
Okay, sure. So just very quickly, the presenting rights, so I can share my my presentation. I believe you should be able to see it already.
Yes, works perfectly fine.
Okay, great. So as Frank already introduced me, I already presented a few weeks ago for vBrownbag. My name is Andrea and I am a CCA in routing and switching for 6985. I work as a network architect, so I hope that I will have a bit of knowledge to be able to share with you. Today's topic is about the router's boot process, and in particular all the operations and all the steps that the router, a Cisco router goes through from the moment you power it on to the moment it actually starts to be operating. Let's go into the details. I mean, what you will see here is that a Cisco router doesn't behave any differently than any other computer you might have been working until now. The idea is exactly the same. What a router will do as a brief summary, from the moment you turn it on, is going actually to make a self-check of the hardware on board. The reason why it does that is only to check that the router is not actually falling apart, making useless to actually boot. I don't know, it could be a RAM memory corruption, it could be a fan which is not which is not working. So there are many reasons why a router might fail to boot doing his hardware checks. Assuming that the hardware is all fine, then the router will try to identify where his iOS image is and take it out of the memory, extract it, and put it up and load it. And once the operating system is done, then it's just a matter of finding the configuration file, if it exists, and load that configuration file to be able to actually operate whatever you guys were able to set up before the router was rebooted. So this is a very high level description. Let's go into the details of these of those operations. So the first real operation the router will perform, as we said, it's a test on its own hardware. So the name of these tests, of those tests, are called POST, which stands for Power on Self Test. Again, this is 100% done on the router, checking basic hardware functionalities, environmental, memory, and so on and so forth. The part of the software which is responsible for the POST test is stored into a ROM memory, a read-only memory, some chip built into the hardware architecture, and every time the router boots, that part of the memory it's read, executed, tested, performed, and if successful, the next part of the boot process starts. Very similar to a computer, the router will start its own BIOS, let's say. It's the bootstrap. Now the responsibility of the bootstrap is to actually locate the iOS image, and that image it's most of the time stored into the flash memory. We will discuss a bit later about different kind of memories, but I hope you already noticed we touched two types of memories, a ROM memory and a flash memory. We will see there are two more which are involved into the boot process, but let's take those details for later on. So the bootstrap will then locate an iOS image, and if found, it will take care of extracting that iOS image from the flash, decompress it, and store it into RAM memory. That's the reason why, especially on the older routers, when the RAM was a primary concern, you couldn't boot a more powerful iOS image without a RAM upgrade. It simply wouldn't allow you to fit the decompressed image into that RAM. Now, if the image is found, then the boot will continue with other steps we will see in a while. But if the image is not found, the router will default into an emergency operating system. That operating system is called ROM-mon, and it will allow to perform some basic operations, including downloading a new iOS image from a remote location, most of the times a TFTP server. Assuming that the image has been found and the router is actually trying to decompress that image, unless you are going to interrupt the boot, the router is going to look for a configuration file. But, I mean, why would you even try to interrupt the boot in the first place? Well, one reason, or the most common reason, is password recovery situation. What that means is that you are maybe managing a router, you configure your enable password a few months ago, never accessed the router ever since, and now what? You don't remember the password. Well, you can do password recovery. You will need obviously physical access to the router in order to do that. You know, it's also for security reason, as you can imagine. But you can actually interrupt the bootstrap operation, pressing the break key on your keyboard, and that will allow the router to fail over into ROM-mon again, and from there do a series of operations like changing what is called the configuration register to be able to set up a password recovery. We will go through a password recovery example in real life, so we will do this operation together. But the most important thing again is that we will need to modify something via ROM-mon to be able to actually do that. So let's say we found our image, we didn't interrupt the boot process, so well, what now? We need to look for a configuration file. If we find this configuration file, we will obviously load the configuration and move forward with the router's operation. We are ready after that. If we don't find the configuration, a wizard will come out, but let's check this just in a few seconds. So once the iOS is loaded in memory, the router finally has its operating system up and running. That configuration file now is looked into the NVRAM. The NVRAM, it's another memory. It's called non-volatile RAM, and that is the place where your startup configuration file is actually stored. If the configuration file is not found into the NVRAM, then the router is going to look into a TFTP server, and if even that, in the TFTP server we are not going to find the configuration file, then we are going to start the configuration wizard and start from a blank for a blank setup. Assuming the configuration file is instead found, the router will take that file from NVRAM, will copy into the DRAM, which stands for dynamic RAM, and that startup config is now called running config, and that running config is, as the name says, it's what the router is executing in that very moment when you're actually accessing it. What that also means is that you can make any kind of configuration on the router, and that configuration is only going to impact the DRAM, nothing else. Sorry, the running config, which is stored in DRAM. If you want to make sure that your changes are actually saved and available to the router for the next boot, then in that case you will need to save the configuration and make sure that your running config has been copied back into the startup config. And from a very high level, from what you need for your CCNA exam, this is all regarding the boot process. Why you may want to actually know those things? First of all, Cisco really like to make questions about the boot process, and in particular, I can tell you by experience that password recovery is required. It's gonna happen to you one way or another. You're gonna need to perform password recovery, and also it also is going to help you in situations when maybe your iOS file is broken. So the operating system, the file which stored the operating system is actually being damaged, memory corruption, like you maybe some mistake in the copy, you reload your router and now you don't have an image to boot from anymore. Knowing how the boot process actually operates and which steps are followed in order is going to help you a lot to actually bring into operation, to bring back into operation a Cisco router which had the problem. From a more visual point of view, this image is probably going to help you, and what is showing you is for each type of memory, or better, from each type of inputs, what is going to be loaded and what is going to happen after that. So again, starting from the beginning, we will perform, we will load the post from the ROM, from the read-only memory, and we will perform our post testing. If the post is actually successful, from the ROM, we will load the bootstrap, and we will start to look for an operating system. First into Flash, if not into Flash, into a TFTP server. This is usually done via ROM-on. If the operating system is found, we proceed. If it's not found, we fell over into ROM-on. Then, assuming the operating system has been finally loaded, the router is going to look for the configuration file first into the NVRAM. If not there, into a TFTP server. If not even there, at that point we will start the wizard and we will ask for input via the console. So this is really all regarding the boot process of the router. What might be of much more interest instead is actually to discuss those type of memories we saw before. The ROM, as the name says, it's a read-only memory. It's a pre-burned memory which cannot be modified. It's written one time by Cisco or by any vendor, because those memories obviously don't apply only to Cisco. They are general terms. So they are burned the first time by the vendor with some basic software which is used to do the minimal basic operation. That is the first memory. Then we have a flash memory. Now the flash memory can be compared somehow to your hard disk on your computer. It's a non-volatile memory, which means that the information stored on that memory is not going to be lost when electricity to the router is gone. So you can shut down the router and your information is still going to be there, but is much slower than a RAM kind of memory, random access memory. So why would you use a flash? To store long-lasting data, to store your operating system, to store your files. It's usually a place where you actually read and write once in a while, simply because it's not as fast as other type of memories. Now the NVRAM, this is very, very similar to the flash. The main difference is that the flash memory, especially on the new routers, can be extracted like a card in a slot. The NVRAM, it's usually a card built, rather than built, but installed into the motherboard of the router. It's much smaller in size, and usually only contains the startup config and few other files like RSA keys or certificates in case you're using features like SSH, SSL, and things like that. The last type of memory is then the DRAM, which stands for dynamic RAM. Usually it's just called RAM memory, which means random access memory. That it's a very fast memory. You can read and write out of that memory like in a moment, very quickly. But the downside of this memory is that if it loses powers, it's going to lose every information you have stored in that memory. That's the reason why a running config must be saved from DRAM into NVRAM to be able to retain the changes you have done. Otherwise, a reboot of your router, a power loss, anything it can come to your mind, will mean a loss of data. So let's see in detail those processes, those steps as they are executed by the router. Let me actually see if I can share something better. I want in particular to share Packet Tracer. You're probably all aware of this software from Cisco. We will see how all the processes are executed. Yes, Frank, you were saying something?
Yeah, I just wanted to mention especially that last step that you mentioned, actually saving the running config into the boot config. That's something very important for the exam if you're doing the lab-based exercises around those, what Cisco likes to call the simulators. If you're not persisting the configuration changes you made, basically you don't score any points, right?
Yes, that's exactly correct. And the worst thing it can happen to you is if you're working on real hardware, or if you are, let's say, on a CCNA exam and your router crashes and you didn't save. So that is what actually happened to me. I was waiting longer than I was supposed to actually make to actually save my configuration. I tried to run a script and that made the DOS crash. The router rebooted. I lost about 1 hour of configuration just because I didn't save it. So my suggestion is to automatically learn to write the configuration in run. If it works, save it right away. I mean, it needs to be almost like a reflex. You don't have to think about it anymore.
Yep, I agree.
I can tell you it was really not nice when I saw my my switch. It was a layer 3 switch reboot and I didn't save the configuration. I mean, that was crazy. Okay then, so I was talking about Packet Tracer. This is a very nice nice software which you can use for your studies. There are several limitations because not all features are available on this software, simply because it's a virtualized actually rather, yeah, it's virtualized, it's software where they only coded some feature, so you don't have the entire Cisco iOS feature set in it, only a limited section, whatever the developers decided to put in. But it's going to be very, very useful to the boot process, try a password recovery, and so on and so forth. So let's go through it. We will see that router and switches, they have a slightly different boot process. Not because it's different in per se, but because the switch performs much more, many more tests in the post part compared to a router. In particular, the switch, it's way more verbose. It's going to check the flash memory. It's going to check all the switch ports, so you know the memories, because the CAN table, because the router is the switch needs those parts of hardware to operate. If a router has an interface on one of his weak cards not working, the router itself might still be able to do something. But if the entire line card on a switch, or if the entire chip which switch's frame is down, then you are not losing just one port, you might lose operations for the entire switch. So this is very critical. So let's try to open a switch. Can you please confirm that you can see the actual switch in front of you? Because I'm sharing the...
Yep.
No, okay.
No, that was fine. Yes, I can see this the switch and the command line interface there. That worked.
Could you see before?
I could before as well.
Okay, so let me switch then to sharing the packet tracer because it will be easier. All right, so I will try to just reload this switch and let's see what happens. So we confirm reload. So obviously there is no hardware, but what we can see here, just give it a few seconds to finish, because otherwise we will lose as we talk. Perfect. So what we can see is that the switch, once it's reloaded, it's going to start is bootloader, which is going to pull from the ROM the post software, and you can see all those checks which are done here. So the router is going to check his X-modem file system, initializing the flash, checking that the flash file system is all right, and then is going to check for the image. Now this part that you can see here, it's all part of the post operations, and on a real switch you can see this only if you are connected via console interface. Now, assuming that everything in this part has been successful, now the router is going to look for his operating system. The operating system, as we said before, it's usually located into the flash, and this file has been found. Now, I don't know if you noticed, but the switch was taking a few seconds to be able to boot. So let me try to do this again, because this is really interesting to see. Now you see now it's loading the image. What is actually doing the switch at this point is that it's taking that compressed file, this bin file, and is decompressing it, extracting it literally. It's kind of zipped basically, and moving into RAM. Once that operation is done, now the router or the switch is going to actually boot the operating system, and you can see that we have some information into the non-volatile memory, and this is obviously the NVRAM. It's not very visible on the switch, but we will see this on the router. If there is no configuration, the router will ask for initial setup. So let's try to load the router, and let's try to reboot it, and to see the similar operation that we did, so reload, that we did with the switch. So again, Here we can see, let's just wait for a few seconds so that we don't lose the output. So the first operation that the router is doing after performing its post is to checking is the bootstrap, right? So we have our memory which has been verified, we are all right with the hardware, the main memory is configured, so we have our ROM which has been which is part of the bootstrap and will allow us to load the iOS image. That iOS image is then found, it's self-decompressed, and once that is done, the router is going to actually boot the operating system and look for a configuration file. So was the configuration file found? Well, not in this case, and as we said, we will get a configuration dialog, we will get a wizard. So in the, usually you want to say no, but if you're curious, just press yes. It just makes you a series of questions. My experience is that this is the most annoying wizard I ever found, and you will see everyone just tell you break it, get out of it. So once you do that, you are now in user mode, you can go in enable and start configuring. So how all this helps? Well, let's try to make a configuration. Let's call this router, I don't know, vBrownbag. vBrownbag. Okay, and let's put our enabled secret, like we put a password for the enabled user, which can be I don't know, vBrownbag as well again. So vBrownbag. All right. So now if I do my show running config, again this is configuration now has not been saved, only exists in running config. I can see that there is my host name and there is my password actually in the router configuration. But if I try to do show, well, where is the startup? We said we said that is in NVRAM, so let's verify that. So let's try to list all the files which are in NVRAM. Well, there is nothing. Why there is nothing? Because the router didn't have a configuration before. Fine, so we will save. How do we save? Copy startup into configuration, copy run config into startup config, destination startup. So now if I check my NVRAM, you can see that we actually have a file called startup config, right? So I can now try to reload this router, and my configuration should be automatically loaded, and no wizard should be displayed again.
And the good thing,
okay.
Even though the CCNA data center is covering NX OS rather than iOS, a lot of the commands are actually the same on NX OS as well. Cisco has put an effort into basically keep the whole CLI navigation point of view the same. The only difference you'll see if you're working with an actual Nexus switch is that unlike on this iOS interface, you won't need enabled mode anymore. That's basically assigned via the roles of the actual user. That's a difference you would need to study up on for the specific data center exam. But the whole boot up process, instead of there, it's called a kickstart file, but the overall process is basically exactly the same for
yes,
NXOS as well.
That's correct, and we might be able to see some of the NXOS thanks to GNS3. I should have an NXOS image we can try to see for our guests to have a look, but the concept can be applied to any kind of a Cisco device you're working on. So if it is an iOS router, if it is an iOS switch, a Nexus switch, or anything else coming to your mind, ASA firewall, the steps are almost identically for all of those. So as we said, now the router actually restarted, our configuration was already in place, and we were not asked for a configuration wizard anymore. So I want to show you just two more things. So let's try to change the host name just into bag. And now if I check my show run, you can see, and again, this is the actually running configuration, is only into the temporary memory, which will be lost if I remove the power from the router. You can see that the host name is back. But if I do a show of the startup config, and that configuration is saved into NVRAM, now the host name is vBrownbag. So it's really important that we actually save the configuration if you want to keep your your changes available for for actually persistent reboot.
Andrea, I think you'll need to repeat that last part again and share your screen and reshare it. After you entered the enabled mode, it kind of froze in here.
Okay.
Yep.
So let me
showing
go
the
back
difference again between running and startup.
Yes,
there. That's what they request.
So what we did, you can see over here that we changed the host name in bag only, and we can see the difference between the show running config, which is actually running in DRAM only, which is showing us very very visibly that the host name is back. But if I check my startup config, which again is the configuration which is stored in NVRAM and persists on reboot, because I didn't save my run into startup, the host name is actually different. So again, we said before that we need to know the router process in order to be able to do some operations like restore a broken OS image or even do a password recovery. So we typed a password in it before, so I will go out and let's say enable, I don't know, I can type anything, I just don't remember the password. So what do we do? Now I need to wait for this to finish, but I can probably just reboot it. So I can just shut down the router, reboot it, and I can stop the boot process. Now this is exactly what I did right now. Again, if you think about the previous steps, we said that the router will go from post into bootstrap. From bootstrap, it will start looking for a an operating system image and decompress it. This is what was happening. Unless we actually send an interrupt. We send a break to the boot process, to the bootstrap, and we will fail over into ROM1. Now you can see here that now my interface is ROM1 1. And what can I do here? The way of using this minimum OS is very similar to what you will do with an iOS or an XOS. Question mark is going to tell you what you can do. So it's very limited. You can just boot and continue with your operation. You can change the configuration register, which we will talk right in a moment, but this is extremely useful for password recovery. You can list file, look for help. You can reset the router. Basically, you can just reboot it. You can set some variables, and you can use a TFTP client to actually download an image to actually boot. So let's see some of those commands. I can run set. Oh, there is nothing really configured. Sorry, set. I can run no, that's fine. I can run set, that's it, without options, and there is no. I can use boot to actually continue my process, and if I do it, you can see I go back into decompressing the actual image. I will break it again. We said now that I don't know my password, so what I will do is to change this information, which is called configuration register. This is a 16-bit value composed of 4 groups by 4 bits, and those bits will tell the router, or better, will tell the bootstrap what to do. In particular, there is a bit which is used to load the startup configuration if available, or it can be used to ignore the startup configuration even if it's present. So in our case, if I want to reset my password, how can I do it? Well, I could start without configuration my router and then become enabled, load the configuration and change the password. So how would I do that? Well, I need to ignore obviously the startup config. If I don't do it, it will just be loaded and will be cut out from the router. So let's give it a try. I can do then configuration register, set a value to 142. That 4 will tell the router to actually ignore the startup config, and once I do this, I will just boot my my router. Now let's see what happens. If it's true what I said, I should still have a startup config, but should have been ignored, and this is what happened. At least it has been ignored. I have a blank configuration right now, a blank running config. Let's see, is my startup still in NVRAM? Well, there is a file. Are all my configuration in it? Let's check. So show startup, yeah, I see my host name, I see my password. So what can I do? I can go again, enable, sorry, I was already, I can do in, from here I can actually load the startup into run, but because I'm enabled, I don't need to type a password anymore. So I can do and say, copy the startup into the running config. Yeah, do this change. My host name has been changed and my password is there. But because I'm already enabled, I can just change and say that my new enabled secret is, I don't know, ABC123. I will do that. I will save. I can actually even do other changes, and now I can reload. Let's see what happens. I should be able now to access the router using the new password, ABC123. See if that is true. Oh, something is wrong, isn't it? Well, we changed the register before, but we never restored it. So we should do actually that that step as well. So we will copy again our startup into run, and we need to restore the configuration register, what we changed before. This time we will restore the default value, which is 2102, and again you can see that we only changed this digit. 0 is the default, 4 tells ignore the startup. I do that, I reload. Now everything should be working as expected. Let's give it a try. Good, I'm here. Enable ABC123. Yeah, I'm in. So as you can see, knowing what the router boot process sequence is, you can actually use it to fix in case you have a broken image which has been saved into your flash. You can reset a password which has been forgotten. You can do a lot of things. So never assume that a Cisco device is going to work all the times perfectly. It's going to happen that something goes wrong, and those steps really help with troubleshooting. Of course, most of them require physical access to the router in order to be done. And the reason is that you will need console access, especially to send commands like a break during the boot operation. This is just security. You wouldn't want anyone to be able to do this remotely, right? Just reload the router and try to change your password remotely. You need to have physical access. But that's pretty much it, Frank. Unless you or any of the guests have any question, I mean, I hope that this clarified the process, the sequence. Might be helpful to give a look to some of the resources. I have in the slide here 3 very interesting links. The first one describes a router boot process and configuration files and memory types in details. The second one describes an example on how you can perform a password recovery, while the last one from Learning Network, it's actually describing in really good detail all different types of memories which you will find on a router: ROM, NVRAM, flash, DRAM, and so on and so forth. So it's either question or otherwise, Frank, the ball is back to you.
Yep. No, I think we're good for questions right now. One further resource also would be just really specific for the exam, because you'll have simlets on them. There is a NXOS troubleshooting guide, and there's a portion in it which is called Troubleshooting Installs, Upgrades, and Reboots, which basically also takes you through all the intrinsic details you need to know from a boot point perspective, all in one nice little document in a single spot. Plus, it has all the other troubleshooting information you'll ever need when running this in a daily life. And I think with that, thank you very much for presenting today, Andrea.
No problem, Frank. Well, my pleasure as last time.
Yeah. Looking forward to hopefully seeing you back again soon.
All right then. Thank you, Frank, for hosting me today, and bye-bye, everyone. Thanks for attending.
Thank you. Take care. Bye-bye.
Bye-bye.